Hi, Assalamualaikum and good morning to Madam Mira. And my name is Ahmad Khairusy Syakirin, and I'm going to present to you today about my research project, which is Bioemulsifiers from Pseudomonas aeruginosa PS.NR.22 for enhancement of biofouling degradation. So let's begin. Biofouling is a major issue in the treatment of membrane water and wastewater, as it significantly affects the performance of treatment processes. Graphene oxide membrane is used as a wastewater treatment tool. After a period of time, the membrane would reduce the efficiency of wastewater filtration. Well, Ramno repeat bioemulsifier generated from Pseudomonas aeruginosa and R22 has unique characteristic for the degradation of biofouling by reducing the interfacial pressure on the membrane layer. The potential to degrade dulang fused crude oil and a synthetic wastewater, which is the yeast solution, is running several tests. The use of a minimal case and minimal ppp gas with glucose as carbon substratum has increased bioemulsifier production. To bind the bioemulsifier to the membrane, the dead-end filtration technique has been used, and it will reduce the cost of fouling with the biological methodology, and it's a chemical-free form. Well, let's moving on to the objective of the research. Well, the major objective for this research project are to review production of bioemulsifiers, which is RamNO-NR22 from bacteria Pseudomonas aeruginosa NR22. And the second objective is to assess the biofouling degradation using RamNO-NR22 and using graphene oxide as the membrane. Well, moving on to the problem statement. So, biofouling is a critical issue in membrane water and wastewater. Treatment as a jet greatly compromises the efficiency of the treatment processes. It is difficult to control, and significant to economy resources have been dedicated to the development of effective biofouling, monitoring, and control strategies. Graphene oxide membrane used as a technique to treat the wastewater. After a period of time, the membrane will decrease its efficiency, and this is due to the fouling issues as the microorganisms stick to the membrane and is block the flow to decrease the efficiency. A wide range of industry in our society already face with this fouling problem. Conventional preventive strategies are chemical based, but this give bad impacts to the environment. Well, recent new understanding of biofouling mechanism has shown that biotechnological approaches involving the utilization of microorganisms or their metabolites might provide effective alternative to using chemicals. The biological method on attachment of RAMNO and R22 to the graphene oxide membrane need to be done. With the biological technique, it will decrease the cost to degrade the fouling, and it is the chemical-free method, so there is no need to spend more money to dispose the chemical waste used to clean the fouling. The bacteria can be isolated and then cultured it to reproduce. This will also reduce the cost to produce the bioemulsifier. Now let's move on to the scope of the research. Well, this research was focused on the ability of bioemulsifier, which is from Pseudomonas aeruginosa, to degrade the biofouling on graphene oxide membrane. This membrane was attached to RAMNO NR22 as bioemulsifier. Bioemulsifier agent to degrade emulsion from crude oil and yeast solution act as a wastewater. The scope of this research includes several phases. The bioemulsifier RAMNO NR22 was first produced from Pseudomonas aeruginosa NR22 by utilizing some medium as carbon source. Then, the produced bioemulsifier RAMNO NR22 will then be extracted before being characterized to compare with the commercial one. Well, and then the extracted bioemulsifier was then been studied on its ability to enhance biofouling degradation in crude oil and yeast solution by using RAMNO and NR22. This will show the ability of the bioemulsifier to break down the industrial emulsion such as crude oil and wastewater. However, it is needed to narrow down a specific scope as there are always limitations in research. Alright, so let's moving on to the methodology part. So in this part, procedures on bioemulsifier from Pseudomonas aeruginosa for enhancement of biofouling degradation will be explained, and this chemical and equipment required for this research will be introduced also. So the methodology was divided into several parts as you can see in the poster. There's a 7 step. So the first step is preparation of Pseudomonas agar, which is we have to prepare the agar. uh, as you can so we have to measure the Pseudomonas powder, and then we have to mix it with the distilled water, and then heated the mixture, and then we autoclave it for about 2 hours at a temperature of 210 degrees Celsius, and then pour the agar into the petri dish. So the next step is the preparation of case minimal. So the case minimal, the first step, we have to mix all together the ammonia hydrogen, potassium sulfate, magnesium sulfate, uh, and a distilled water, and then we have to mix all together in a conical flask, and then we have to adjust the pH until it's become 6 by adding the sodium hydroxide, and then the minimal was then autoclaved about 2 hours, and then store in the fridge. So the next step is the preparation of the PP gas medium, which is also we have to mix all the medium inside the conical flask, and then we have to mix and adjust the pH until 6 using sodium hydroxide, and then we autoclave it for 2 hours and store it in the fridge also. So the next step is step 4, which is the production of bioemulsifier, which is the first step. We have to culture the Pseudomonas aeruginosa in a centrimat agar, and then we wait for 24 hours, and then the cell was then inoculate in a nutrient broth, and then wait another 24 hours, and then we add 1% of nutrient broth was then transferred to case minimal medium that we prepared before, and then we have to wait about 2 days, 48 hours, and then the 6% case minimal medium then was transferred to PP gas medium that we have prepared before, and then we have to wait 72 hours, and then the bioemulsifier was then produced. So the next step is extraction of NR.22, which is the first step is a sample placed into the conical centrifuge tube, and then we need to centrifuge it at 900 rpm at 15 degrees Celsius for about 15 minutes. And then after obtaining supernatant, adjust the pH to pH 6 using 1 molar sodium hydroxide, and then the final product will be the honey color bioemulsifier will be produced. So moving on to the step 6, which is the attachment of NR.22, which is we have to attach the bioemulsifier that we prepared before into the membrane using a dead end filtration. And then the step 7 is where we study the biofouling degradation by NR.22 on a graphene membrane. Let's moving on to the results. So factor influence the development of rhamnolipid can be divided into 2 major classes, such as the environment and the availability of nutrient, pH, temperature, and oxygen, which is the essential factor for the growth of microbe, and as well as the amount of the quality of the substances. Well, activity environment factors such as like pH, temperature, agitation, and oxygen availability play important role in microbial growth and rhamnolipid production. So, optimum rhamnolipid production by Pseudomonas aeruginosa was obtained at 37 degrees Celsius at pH 7 and 200 rpm agitation. So for the nutrition factor, according to the most report, varied biology attribute of Pseudomonas aeruginosa makes it essential to consume a broad range of substrate, which are not always easily degraded by the certain species. The findings shows that glucose and glycerol were efficient carbon substrate for rhamnolipid growth after 7 days of cultivation. The culture with glucose produced about 0.3 plus 0.01 deviation gram per liter of rhamnolipid, and for the dry cell where it was 2.9 plus minus deviation of 0.02 gram per liter. As you can see on the table, the glucose gain highest amount of rhamnolipid yield, which is 0.3, compares to the glycerol, sucrose, hexane, oleic acid, olive oil. And this shows that the rhamnolipid is very like to glucose. So next, moving on to the biofouling degradation of membrane. A rhamnolipid concentration more than 300 milligram ml at an exposure time more than 6 hours resulted in a decrease in biofilm reduction because the cleaning rate reached a steady state with organic matter or bacteria on the biofilm layer being reduced at 300 milligram per liter after a 6-hour exposure time. As you can see, on the graph, there's a and B. So the graph A is shows a reduction in total cells number when applying about 50, 100, 300 or 500 milligram per m per L rhamnolipid treatment about for 2 hours, while figure B shows effect of various exposure time about 1, 2, 4, 6 or 12 hours when 100 milligram milli per liter milliliter rhamnolipid were applied. So moving on to the crude oil degradation, based on the graph below, as you can see, the MSMCBCB is gain the highest biodegradation, which is in that solution, it's contained biosurfactant about 3% volume per volume. So based on the 5th day, 10 days and 20th day of observation, it is finds out that MSMCBCB solution have a high percentage of biodegradation of the film. So the result of the biodegradation experiment shows that the biodegradation of crude oil was enhanced by Pseudomonas aeruginosa strain C1501 as bioemulsifier was used, and then it shows that the bioemulsifier act as an effective enhancer for biodegradation of hydrocarbon. So let's move on to the conclusion and the recommendation. Production process of the N.R.22 bioemulsifier recorded several significant results. The biosurfactant has been improved by adding appropriate carbon substance and nitrogen source in the medium, thus enhance the stability of the bioemulsifier. Both the brownish color and the presenter form suggested bioemulsifier development was successful. A high degree of foam stability indicated high bioemulsifier stability. The bioemulsifier provided by N.R.22 has an almost similar chemical characterization with the commercial bioemulsifier, which shown the thrive in the bioemulsifier production. Rhamnolipid is of all bioemulsifier best studied. Rhamnolipid find promising implication for MEOR activities within the petroleum industry. And then using rhamnolipid information as a model bioemulsifier, it is recommended that there is far more to be explored for other bioemulsifiers in terms of their industrial and environmental application. Currently, high production costs limit the commercial success of bioemulsifier. The utility of bioemulsifier has been clearly demonstrated in the reducing biofouling of hydrocarbon mixture. Not only was the bioemulsifier effective, but it also had the advantage of being biodegradable. A few other recommendations are provided which obtain a higher purity of bioemulsifier by broadening the studies using different carbon sources apart from glucose. The temperature and the pH can also be exploited to enhance the bioemulsifier result. In addition, various species of bacteria need to be attached to the membrane to degrade another compound in the crude oil or wastewater. Continuous framework will need to be incorporated. The reusability of membrane study. So that's all for my presentation. So I would like to bid a thanks to the examiner, Madam Mira, and then to my lecturer, Dr. Nick Raham, for giving me a chance to do an experiment, and to all my friends who helped me through doing through the day and night doing the research project. But then the pandemic came across and it will disturb all our research. And thank you for listening with it. I don't know if it's sufficient or not, but I think it is what it is. So thank you very much.